Hello, welcome everyone to question number 7, remove loop in linked list from the topic linked list of Geek for Geeks must to do coding questions. Just have a quick look at the questions and after that we'll be discussing the approach. Now before discussing approach, I want every one of you to subscribe our video. If you have any doubt, just leave a comment below. And if you have any extra email IDs, I request you to subscribe with those all accounts. That will be very helpful for our channel to grow. Now let's go to the approach. Now coming to the approach here, we have to understand the question first here. Let's understand the question first here. So in this question, it is saying we have to remove a loop in a linked list. And the example given is 1, 3, 4. It was given as 1, 3, and 4. This is the linked list that we have been given. And in the example, if you see in the Geek for Geeks website, this is the example that is given that there is a loop from 4 to 3 and this 4 is assumed as the second position. Okay, this is assumed to be the second position. If you think this as the second position, then it should start from 0, 1 and 2 only. So only in that way that is possible, that is the second position. Now coming to the question here, now we have to find out the loop is starting from 4. How will we do that, right? First we have to know that there is a loop. Okay, so let's see how we can do. So there is a simple approach where we use two pointers. One we name is slow pointer, okay, and another we name is fast pointer. I'm writing this as FA here for simplicity. So this LA moves one step ahead and this FA moves two step ahead. By step ahead means like why one step ahead. So this both will be initialized to initially to head, right? This both will be initialized at the one position here at the start here. Okay, now it moves, slow position pointer moves one step ahead, right? So slow position pointer will come here and fast position pointer at the first iteration, it will go two steps ahead. So these arrows, you just keep in mind, you have to keep in mind these arrows, okay? One step and this is two step. So at the second step, it reaches this fourth value position. So we have fast pointer here. This is in the first iteration. And in the second iteration, the fast pointer will go two step ahead, right? Before that, let's take the slow pointer here. So 1, 3, and 4. Now you can guess where the slow pointer comes. One step ahead, that means it will go to the next arrow. The next arrow is pointed towards here. Okay. Now if you see the fast pointer in the previous first iteration example here, if you count two steps ahead, 1 and 2, it will come here only again, right? It will come at the same place because it is moving two steps ahead. So here slow pointer and fast pointer have met at some point, right? It can be any point. In this example, it is coming in the last of the linked list, but it can be anywhere. It can be at any other position also. So there is no fixed value that they will meet at a certain point, right? Because you may think that slow pointer, fast pointer have met, and the next arrow is the arrow which is creating a loop, right? But we don't know that exactly. We can only confirm with slow pointer and fast pointer that there is a loop. If both of them meet at certain point, then means there it is a loop. If there is no loop, then slow pointer and fast pointer will terminate. How will they terminate? There will be a none value, right? The last value address of the linked list will be none. If there is a no loop, right? If there is no loop, simply go to the none and it will exit it. Since there is a loop, they will both meet at some point, right? Now this is how we detect that there is a loop. This is the first step here. This is the first step. We detect the loop. First step, detect, right? That we have done successfully. Now since the second step, what we have to do is after detection, now we have to find out where exactly we have to remove the loop. By visually viewing, we can say we have to remove the loop at this point. But how will we say in the code, right? So this is the first step. Now we know slow pointer, fast pointer, more that now there is a loop, right? Now we take another here example here. Okay, let's change the color of the pen. Let's take yellow now. Okay, now I'm writing down below here. Okay, now let's now check here. Slow pointer, fast pointer at the same position. Now what we are saying is we will reinitialize slow pointer to the head position. Okay, after reinitializing, this is how the linked list will look. 1, 3, 4, and fast pointer will be here, okay, and slow pointer will be here. Now there is another condition here. Now the slow pointer, okay, slow pointer and the fast pointer, this is slow pointer and this is fast pointer. After detection of loop, this happens, right? After detection of loop, this happens, okay. Then we say this both pointers should move by equal distance, that is one step. Earlier it was one step ahead for slow pointer and two step ahead of for the fast pointer. Now after we have detected the loop, that there exists a loop, Then we apply this second method, which is exactly removing the loop. Second, we have to remove. In first, we have detected that is a loop. Now we will remove that loop. Okay. This is the second method we will remove in this. Okay. Now apply the conditions and check, right, where they can meet again. Now I'm removing the topmost explanation here so I can explain the next step. Now I have removed the topmost part here. Now let's continue our next step of the remove. Right, now let's follow these conditions and write the next step here. Right, now following these conditions we are checking first if the next element is equal or not. If equal, then only we change the position, or else we won't change the position. What I'm saying is this is SL here in this, right? Now I'm saying dot next element. Dot next is this arrow, and this arrow is pointing towards this 3 position here, right? And fast also. This is 4 here, and dot next will be this 3 position again. Now we have to check if the next position is equal or not. So if you check here, slow dot next will here. Okay, now I'm writing dot next, but we will only write if it is not equal. Okay, if it is not equal, only then we write 1 3 4. And now check slow dot next is this one, slow dot next is this one. We are not rewriting it, we are checking here. But in the condition, if condition, we are checking, right, if dot next is equal to fa dot next or not, right? Fa was here earlier, now dot next will come here only. So FA and SL, both of them are equal here in a dot next representation, and we haven't reinitialized with SL and FA. We haven't done that because if we reinitialize, okay, if we reinitialize and write as it is, in place of this SL dot next, if we keep SL, if we keep FA, now we won't know the position of the loop where it is recurring, right? We won't be able to know. But if we don't rewrite this, if we don't rewrite and we are just checking dot next is equal to other first dot next or not. So SL was here, okay, SL was here previously and FA was here previously. We just check here without any rewriting. Now check FA dot next equal to SL dot next or not. Yes, it is equal. Then that means the FA dot next is the point where the loop has been occurred. So we just come out of the while loop or for loop, any loop we are using, we come out of the loop and we can guaranteely say that if a dot next element should be rewritten as what? That should be rewritten as equal to null value. Okay, this should be rewritten as null value. Now after rewriting this, we get 1, 3, and 4, and this will be pointing towards the null value. So this is the new linked list that we get after removing that. So if you haven't understood the second part of remove this one, I recommend you to watch the coding part also. After that, I'm 100% sure your doubt will be cleared. Even if it is not clear, please help me to understand where you are facing the problem by commenting down in the box where you are not able to understand, and I will help you there as soon as possible. Now let's go to the coding section part. Now we are inside the coding section part, and I have discussed slow pointer and fast pointer. We are copying the head element there, head position address. And after that, there is this one small pointer, slow pointer. There's another pointer, fast pointer. This is moving with one step ahead, and this is moving two step ahead. And we are using a condition inside the while loop. If slow pointer or fast pointer or fast dot next pointer, if they are none values, then it will exist from the loop of while. Okay, then that means there is no loop here. So that's why we're using this condition to ensure that there is a loop and we can repeat this step, right? If the both pointers meet at one position, then means there is a loop. Now there is a loop. Now we break out of this loop and we say if slow pointer is equal to a head position. Now we are checking. Okay, now slow pointer, fast pointer have met at one position. Now the slow pointer is, if it is at head position, by any chance if the slow pointer is at head position, then that means we have to move fast pointer one time till it is equal to the slow pointer. Okay, because there is a loop, right? If there is a loop, it will meet at some x point only. So before meeting at x point, that is a recurring loop, right? Before meeting x point, that is a recurring loop here. Now suppose this is the start of the linked list, slow pointer. Now let's suppose say fast pointer has went to the end of the linked list. Now we checks at the end of the linked list that there is a loop and that is pointing toward the start. Now that point only we are checking that if it is pointing towards a head address or not. So at header address is also equal to slow address here. So we are checking if fast.next is equal to slow or not. If it is not equal, we simply reinitialize fast variable. But if it is equal to the slow pointer, in the condition, we rewrite fast.next equal to none. Now this fast.next is a loop that is in the linked list. Now we are removing that loop by using none value, right? If the slow pointer is not at the head position, okay, if it is not the head position, then it's fine. Now both are equal in this condition. We're using that slow equal to fast condition. Yes, it's true. Now slow, we reinitialize slow pointer to the head address. Okay, now slow pointer will move to the head address here. Now here we are forcibly moving this slow pointer to the head pointer in this case. Now after that, if while loop slow dot next is not equal to fast dot next, this means we are checking the dot next element that I have explained in presentation. I told that we are checking the address, the next address inside the if condition I told, right? So this is a while loop. We're doing the condition check inside the while loop here. So if this condition satisfies, then only it will rewrite. Before that, it will check if the next element is equal or not. If it is equal, then it will come out of the loop. Then that means the next part is definitely where the loop is occurring. Then we will make it none here. So this is the explanation of my code that I have written. If you have any other code, you are free to share, and I will be uploading your code. If I have enough time, I will upload it in naming those as a second method, a third method of this. I hope you have understood the question. If you still have any doubt, just leave a comment below. And I thank you very much for you watching till the end. And let's meet in the next question. And please don't forget to subscribe. Okay. See you in the next question.